Okay, welcome to section 1.2, functions and graphs. This section is a little bit longer, so I've broken it up into two different sections. So this is 1.2a, and then 1.2b starts on page 5 of the notes that you've printed off for yourself. So we're going to stop when it gets to transformations. So first we just need to talk about functions, right? You first learned about functions as a function machine. A function is a rule that assigns one and only one unique output for every input. We call the input the domain and the output the range. So here we have our little function machine. So say my function is absolute value of x, then everything that I put in, say I can put in a 5, well then I get out a 5. Okay, I have a unique output for every input. Well, what if I put in -5? I would still get out 5, but for -5, I just have the one output. Okay, I can have different inputs give me the same number, but for each input, I have to have one output because it has to do the same thing to every number that I put in there. The formal definition is a function from a set D to a set R is a rule that assigns a unique element in R to each element in D. That says exactly what I was saying in the first part, only more formally and more confusing sounding. The vertical line test is a graphical interpretation of this definition. Of course, you guys know how that works. If I take any function and I draw vertical lines through it, and if it only passes through the function once, then it is, in fact, a function. So an example of something that would not be a function would be if I put a parabola on the side, and there are many places where my vertical line will pass through the function twice, so therefore this is not a function, and the one on the right is a function. Next, domain restrictions. There are 3 domain restrictions that you must continue to be aware of throughout this course. What are they? Well, we cannot divide by 0. Or in other words, 0 can't be in the denominator. The second one is that we cannot take the square root of a negative. A negative number. More specifically, I can't take an even root. So I can't take the square root, the fourth root of a negative number, right? There's nothing to the fourth or to any even number that gives me a negative number. And the third one is I cannot take the log, or natural log, or log base anything, of a negative number, or 0 of a number less than or equal to 0. Okay. So I'll do an example of that on the next page. Or in 2 pages. Both open and closed intervals have endpoints. If the endpoints are included, then we say that the interval is closed. If the endpoints are not included, then we say that the interval is open. Of course, it can be half open and half closed as well. We use parentheses to indicate open. So in this example here, right, that would be from A to B, everything in between, but not including A and B, and a bracket to indicate closed. So that's my first example, from A to B, including A and B. Identify the domains of the following functions. Okay, so now we're combining our functions knowledge with how to write interval notation. So in my first example, okay, you see that I have x in the denominator, so therefore x cannot be 0. But we also have the square root, so whatever is under the square root always has to be greater than or equal to 0. So I have 9 minus x squared is greater than or equal to 0. I'm going to put the x squared on the right-hand side. How do I solve when I have a quadratic in an inequality? Well, we're supposed to solve for equals, right? And then do test points. So if I have 9 equals x squared, that happens when I get x is plus or minus 3. Okay, then the way that we did it in pre-calculus was we said, okay, if I have -3, I have 3. Add -3 and 3, it would give me 0, so those will work. And I need to see, well, does it work before -3? Does it work between -3 and 3? Or does it work when it's greater than 3? Okay, so let's plug in 0 first. So if I plug in 0 into my original function, I get 9 minus 0. That is, in fact, greater than or equal to 0. And I have filled in points at -3 and 3 because it's greater than or equal to. If I plug in a 5 and I get 20, I have 9 minus 25. That is going to be a negative number, so that does not work. Same thing if I have negative 5 squared, that's still 9 minus 25, and that does not work. Okay, so the easier way to do this, though, I think would be after this step, get a new color, so after this step, when I have x squared is less than or equal to 9, is to think about what the graph looks like. Okay, if I have x squared, and here's 9, here's 9. Okay, well, where is it less than or equal to 9? Obviously, my function is less than or equal to 9 right in here. Here it's above, here it's above, so everywhere between negative 3 and 3 inclusive, okay, I get that it is less than or equal to 9. Okay, I think it's a lot quicker than doing the test points, but either way gives you the exact same thing, of course. So now both things need to be true in order for f of x to exist. So I need to have the fact that x does not equal 0 in order for us to not divide by a 0, and I also need x to be between negative 3 and 3. Okay, so how do I combine those two things? Well, it's everything between negative 3 and 3 except for 0. So my final answer is between negative 3 up to 0 and then 0 to 3, including negative 3 and 3 and not including 0. And then my third thing for domains was taking the log of a number. And we said, well, if we take a log of a number, we can't take the log of 0, we can't take the log of a negative number. That makes sense because we know that ln of x looks like this. And we can see we can't plug in 0 because we have a vertical asymptote at 0, and we can't plug in anything negative because there's nothing there. So whatever I'm taking the ln of, I say that that must be greater than 0, and then I just solve for x. Oh, no, it's easy. So negative 3 has common infinity. And of course, we still love interval notation. Yeah. Next slide. Range. Well, it's usually easier to just look for the 3 restrictions in order to determine the domain of a function. The range can be tricky without looking at a graph. Of course, if you're looking at the graphing calculator, then it should be very easy to figure out the range. Well, for the most part. Since we won't always have our graphing calculators, half of the AP exam is with a calculator, half of the exam is not with a calculator. You need to know what the graphs of some basic functions look like. So say, for example, I start with x squared, y equals x squared, and I want to figure out what the range of x squared minus 3 is. Well, if I can understand how transformations work and that I'm just shifting a function down 3, and I remember what y equals x squared looks like, then I can easily figure out the range, which would be negative 3 to infinity, okay? Including negative 3. So that is the purpose of knowing our fundamental functions. These are a little bit different than the fundamental functions that we did last year in pre-calculus. For example, we don't have a logistic function in here, and then these x to the thirds and x to the 2/3. Those are new. I don't think those were in the book last year, but those are functions that we really do use in calculus. I'm not just throwing random functions up there. So your job is to be able to accurately sketch all of these functions, and there are more, don't you worry. Label at least 3 points on each of them, identify the domain in the range of each, and that's it. Okay, I'm not going to do any of the other stuff, right? Is it bounded? What are the maxes and the mins, right? You should be able to do the max and the mins from doing the range. So I am not going to go through all of these. This is up to you guys to do. Most of these you should be able to do on your own, but like I said, the x to the 1/3 and the x to the 2/3, you may need to use your calculator for since we did not do those last year. Okay, and we are going to stop there. So your homework is to finish those equations and to write the domain and range for each of them. Just so you know, for tomorrow, you are going to watch the rest of the video, the 1.2b video, which is a little bit longer than this one, and you will finally have bookwork, okay? So for day one, that's tonight, you do not have any bookwork. You only need to do the examples that are in the notes for homework. Tomorrow you'll have your bookwork, okay? And then we'll do more examples in class tomorrow. And that's it for me.